What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series and the third person fighter specifically, we're going to be making the ability to orbit. So orbiting is a term for when one object rotates around another, just like planets orbit each other, that sort of idea. So as we come into the game here, you'll see that with our 3D fighter, the characters are always facing each other due to some behavior that we set up in the previous episodes of the 3D fighter. Then we also had the ability to walk forward and backward. Now we have the ability to do this, and the rotation still occurs, but we orbit when we walk this direction. So we can still walk left, and we can still walk right. We can still jump, crouch, do everything like normal. But we can also orbit the characters now. I don't have the walking animation in right now, even though we set that up in the 3D fighter, and I'll explain why. It'll become apparent as we're going through the logic. But this is how we can orbit and actually move around the characters in a 3D fighter sense, like in Tekken or Soul Calibur. So we can still walk back this way, and then we can walk this way, back and forth this way. Now the left and right keys still just move us left and right, so when we're orbiting like this, even though this is working as intended, we should also move left and right based on the direction we're facing. But we're not going to be covering that part in today's episode. We're just going to be going over the orbit itself. This is how we know we're walking the right direction when we go farther away or toward the camera. So our 2.5D fighter to 3D conversion is going along pretty well. As I mentioned in all these episodes, this is not actually replacing the fighter series that we have. This is an addition. If you want your game to be in 3D, like in Tekken, you follow these episodes after following the fighting game tutorial series. These are not required if you want a 2D fighting game. You don't want this 3D movement. And just remember, if you're following this series, then make sure you do all the changes that we mentioned in the earlier episodes of converting the 3D fighter, such as removing the constraint on the x-axis, allowing the characters to actually rotate instead of just flip, and everything else. Now, before we hop into this episode, if you want to get caught up into the entire fighting game tutorial series so you can see how we've done everything from our movement, our attacks, hitboxes, those sorts of things, then feel free to click this icon in the top right corner right here to go to the entire playlist. Alternatively, if you don't care about that and you just care about the third-person conversion, even though we are building off of the fighting game series, I do recommend you watch this episode and all the episodes related to the 2.5D to 3D conversion that we've been covering right here. I'll link you to the first one. That way you can get caught up and be on the same page that we are for the 3D fighter. With that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series. We're going to be doing everything in the code today. Visual Studio. And specifically, we're going to scroll down to our Move Forward 3D function. It looks quite a bit different than the last time we saw it, because previously we just did this. So we were ignoring all the actual constraints of a fighter, and in this case we were just adding movement input. That way we could actually move forward and backward on the x-axis that was previously locked in the non-3D fighter. But we're adding everything else in this function today to allow us to actually determine a distance between the characters, determine where they should orbit based on that, so their orbit rotation and their orbit position. Now remember, Move Forward 3D is an input axis, so it has a value that gets passed into it. If it's 0, then neither the forward or backward input is being pressed. If it's 1, the forward input is being pressed. If it's -1, the backward input is being pressed. Now, first thing we want to check for in here is if there is another player. So if other player, basically if the thing we want to orbit around exists, we want the characters to rotate around each other when they move. And so if there's no other player, we can't actually do what we need to do to get this effect. So if other player, basically just checking if the other player is valid or the other active character is valid. If it is, the next thing we need to do is determine the distance between the two active characters. We can get the X, Y, and Z distance if we want. We don't necessarily need all of those. Mainly, we don't need the Z axis because that's our height. The height doesn't matter for our orbit. It's fine to calculate and use it here, but we're not going to use it for anything. But the X and the Y axes can be very, very important in this operation. So F vector, distance between characters, equals. We're going to take our current location, which we can get by typing get actor location, and subtract the other player's get actor location. Easiest way to get the distance between two objects is just subtract their locations. So this is how far apart they are from each other. Very simple stuff here. Now what we have to do is calculate the orbit rotation, or essentially where we're going to want to position the character based on a few values here. So the first thing is going to be our inputs, so what the player is pressing to control their character, or their direction, or the value. The speed at which we want to rotate them, which is determined by our character movement's max walk speed. That's what we set up in the fighting game tutorial series. You could make a separate variable for it here if you wanted, but it's not required. I wanted to base it off of max walk speed because if there's a faster character, they can orbit around the characters faster. Alternatively, make a new variable, set that. You could also change this per character, so you won't lose anything if you do it that way. Then we need the time that has passed. So get world, get delta seconds means it's going to determine the amount of seconds that have passed since the last frame. This is basically the same as the delta time that gets passed into tick, but this is retrieving it outside of tick. We're in our move forward 3D function. This is important because we need to know how far that character would rotate around the character in that amount of time. So if more time has passed, we want to go farther. If less time has passed, we don't want to go as far. Then I have a hard-coded value here, 0.3f, which this is going to be what I call the orbit multiplier or orbit speed multiplier, something like that. It's basically me finding that the max walk speed was a little too fast for the orbiting speed. I do want it to be influenced by the character's max walk speed, but I think it was a little too fast on its own, so I just multiplied it by 0.3f to make it smaller. We're going to convert this to a variable in this episode, but this is how I've set it up for now. So now that we know what all the variables are, we can make our actual orbit rotation. This is the rotation we want the character to be at, given these parameters. So we have f rotator, orbit rotation, and we're giving it a 0.0f as the x. We're using our value, multiplied by get character movement max walk speed, multiplied by get world, get delta seconds, multiplied by our orbit multiplier of 0.3f. And then we're passing in a 0.0f on the z-axis. Once we calculate this, we need to set the distance between the characters equal to the orbit rotation dot rotate vector passing in the distance. So rotate vector is going to determine, based on a distance, where the new location or new distance should be from the character. In the internals, it uses a rotation matrix to determine where this new distance between the characters will be. Remember, this is a vector, so it's a distance on the x, y, and z from the characters. It's not just one value, and that's why we need to do this. So distance between the characters equals that orbit rotation dot rotate vector and passing in the distance between the characters. The return result is the new distance between the characters after the movement has been applied. Once we have this value, we need to actually update the actor's location to that new value. However, that's not the correct value. That's the distance between them. So we need to take the current location and add this distance to get our final result. So we're going to calculate the orbit position and move the character to it. So f vector, orbit position, equals other player, get actor location, plus the distance between the characters. That gets us our final result, and that's where this character that is moving should actually be placed. So we're going to call set actor location, passing in orbit position. This is going to move the character. Now notice, we're calling set actor location, not add movement input. Add movement input is actually applying an input, the value that the player passed, then moving the character. This is normally fine. This is how we do our move left and move right now. There's a few problems with this for this orbit scenario, and the main one is rollback netcode. The add movement input is not fully reliable for rolling back. There are ways you can get around any issues with this, so you can track your values, reset them if you have to roll back a frame. A lot of this causes problems because Unreal physics are non-deterministic, and so rolling back isn't always valid. You could do some stuff to make it work, I'm sure, but it's far, far easier and less cumbersome if we just set the actor location. When we do this, however, we don't have the proper movement in the direction we need to apply the blend space animations that we set up in the 3D fighter, and that's why you weren't seeing the 3D walk animations earlier in the episode. This is perfectly fine. It's not an issue. In fact, the way we handle it in Move Right actually will work for making our animations work in the 3D fighter with this method. This is something we're going to go over in the next episode of the 3D fighter conversion, so don't worry, but just be aware that's what's going on. That's why the animations aren't working with this new system. This is all in the if statement of if other player. However, we also have this else statement. This else statement is doing what we were previously doing in the move forward 3D function, and I think this is still valid. If there is no other player, we can't orbit, but that means we can still allow the player controlling this character to move them in the given direction, so they can move backward, away from the camera, or forward toward the camera. This is good for if you have any sort of story or beat 'em up kind of style where you still want to move them in the given direction the player pressed, but you don't have a target to orbit around. This could also be good for things like when characters are switching out or between rounds if you want to allow them to adjust this way. It's not something required, but I think it could go over pretty well, and you have a few use cases for it, so I kept it. Now let's go ahead and change out this hard-coded number with a variable that we make. So instead of 0.3f, let's go to our fighter template character.h file and scroll down. I'm going to go to my other float variables, and specifically I have some other variables with the modifier word in them for our hitstone and such. I'm going to make a new one here, and this is going to be the modifier value for orbiting characters in three-dimensional space. So this is just basically the speed modifier for that. We're going to make a U property of edit anywhere blueprint rewrite so we can edit it and access it in the blueprint. And then we're also going to give it a category of movement just so it's easier to track. And this is going to be float orbit speed multiplier, or modifier, let's call it actually. Going back to fighter template character.cpp, we can now replace that 0.3f with our orbit speed modifier variable. After this, we're going to need to go to our constructor, which is the function where we set all of our values for our variables at the start. And let's go ahead and add this one here. So orbit speed modifier equals 0.3f, because that's just the arbitrary value that I liked for the base characters. Once you're done with all that, you can go ahead and launch your editor again. You should get the results you saw at the start of today's episode. Anyway, guys, that's all I got for you today, so thank you so much for watching. If you enjoyed this episode, then please subscribe. It really helps me a lot, and I would greatly appreciate it. Speaking of, everyone who's supported me on Patreon, YouTube membership, and Discord subscriptions, thank you all so much. I really appreciate all the support you guys give. If you had any issues or are interested in learning more about this game and this project, then feel free to join the Discord community. There's a link in the description. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.